First off, thank you for coming to the talk. Thank you for sticking it out to sort of one of the last sessions and coming to our talks. I really appreciate it. Thank you very much. My name is Mike Flasco. I'm a program manager at Microsoft. More specifically, I'm the program manager for the ADO.NET Data Services Framework. How many people were able to attend one of the earlier talks that touched on the ADO.NET Data Services Framework? It was likely given by Pablo. If you just a show of hands would be great. Cool. So a fair number of people were able to attend. So what this talk is going to be focused on is it's sort of an add-on to the talks that were given earlier in this conference. And what we're going to do is we're going to not so much look at the deep dive into all the features of ADO.NET Data Services, but instead step back a bit and look at, if we were to go and try and build solutions or rich web clients like Ajax clients or Silverlight clients or a rich data service tier to drive those types of clients, what are some of the common problems that we face when we're trying to build these solutions, and how can ADO.NET Data Services, or can they, help out to solve some of those issues? And so that's what this talk is generally going to be focused on, a little bit of a higher level or an app-centric look at ADO.NET Data Services. For those who haven't seen data services before or haven't seen Astoria, I'm going to do just a brief walkthrough. It'll be sort of the very brief executive summary of what they are, what problem we're trying to solve, why do you care. Once we've done that, we'll look at a few of the key problems we face when we go and try and build data-driven Ajax, Silverlight, rich web clients, and whatnot. And then for each of those problems, we'll look at how data services were architected to help in that space, what level of support do they give you in various situations, and whatnot. So walk through that. I'll spend the majority of my time looking through at kind of a problem-solution type approach with the talk. And then at the very end, we'll spend a few minutes touching on, okay, we talked about what ADO.NET Data Services are in V1, and then we'll spend a few minutes talking about where we're going in the future, some of the problems that we're looking at. And this is an area that we'd really like your feedback on. So we'll kind of split it into two as we go through the talk. So you've probably seen this slide before if you attended one of the earlier talks. This is kind of the all-up, what are data services slide. It's kind of the problem statement for data services. And when we went out and when we set out and started looking at the space of Ajax applications and rich web clients and Silverlight apps and whatnot, we noticed a few key things as a team. The first was there's a lot more just pure data being exposed on the web. This is making things like mashups and whatnot possible, where it's just pure data for you to go consume and integrate into your app. The second key sort of characteristic that we see is that when people are building Ajax and Silverlight apps, and this is nothing new, it's inherent in the architecture of these apps, is that what's happening is all the presentation information, all the behavior information, or all the smarts of the app are being pushed all the way down to the client tier with the goal of providing a richer, more interactive, crisp, data-driven user experience. And so we were looking at that and we were saying, how are people building these data-driven apps today? Is there any room for us to help? Do we need to go do anything in this space? And so we started sort of looking at, if I had, say, an Ajax application, and my Ajax application was maybe I was a salesman, I'm trying to build my app, I'm trying to get my company's CRM data, so like customers and orders and that kind of stuff, and I'm trying to get it down to my Ajax app to drive my user experience. And so we looked at that space and we said, how are people building that today? How are they passing data between the client tier and the mid-tier? Because traditionally, we were writing a lot more code in the mid-tier where we had direct line of sight to our data store or our database. And so things have changed a little bit. And how are people going about doing that? And immediately we could all come in with a bunch of different ideas on how you'd go about serializing data from the mid-tier and pushing it down to your Ajax app. And there didn't seem to be anything new there. But then as we started looking through the space, and I'll use the example of CRM again, when we looked at the space, we said, how would you go about passing customers' information down to the client and orders information, and the fact that there's orders for a particular customer? And then what if my customer set is very large? I probably don't want to pass the whole set, so I want to have some type of paging constructs. And then what about ordering? And what about the fact that there is a relationship? Is that a first-class concept? Is it not? Then we started to think of all the interesting ways that these Ajax apps would want to get at this data. And it turned out that if we took a traditional approach to building out data services or web services, I'd end up writing a whole lot of remote methods. to support that type of rich data access experience to get customers and orders and the orders related to a particular customer. And so we said, wouldn't it be great if you could have a data tier or a web service tier that was driven by the schema of your data? So if what it is that you're passing around is pure data and it's not so operation centric, wouldn't it be great if I could give you the schema of the data and have the system build out these remote methods and this service tier for me based on the schema of my data? And so that's what we're trying to build with ADO.NET Data Services is given a data model, effectively what we do is we have an addressing scheme to point at any of the interesting things you might want to get at in the data model. And then we use a REST-based approach to go and interact with the data. And if you're familiar with REST is basically a set of common semantics for how to go and interact with certain pieces of data. And so to make this concrete, what I'm going to do is walk through a very brief example. You might have seen this at an earlier talk, just so that we all get on the same page, and then we'll dive right into sort of the real world piece of the talk. So hopefully this comes over nicely with me. So what I've got right here is I've got a data model, effectively. It's the same type of thing, my CRM data. It's got customers and orders, and you can see that there's some relationships going on between the two. And the way that the ADO.NET Data Services framework works is, given a data model like this, you new up our service class, you point it at a data model, and then it goes and builds a service tier for you. And so let's just look at what that would look like. So I'm going to run this app. And that's not what we want to be looking at. And what I've done effectively is I've hit the root of an ADO.NET data service. And what it's done is it's inspected that set of boxes and lines that we just looked at and presented me with all the entities that exist in that data model. And the way the system works is it's fairly mechanical in that you take any one of these entities that have been presented back to you, and what I'm going to do is append that directly to the URI. So I'm going to say /product, hit enter. And what the system did right there is it effectively said, give me back all the products that exist in that data model. And I haven't talked about how the data is stored and whatnot intentionally, because we'll get into that as we go. But what we can see is that a bunch of products ended up coming back. And we're just looking at an atom representation of the data, but in typical web service fashion, the two are decoupled, meaning we can ask the system to give us back different representations of the data, such as JSON and whatnot. But I'll play with atom for the majority of the talk. So if we look at any one of these particular pieces of data, you can see that each one has sort of an edit link, and it says that, oh, by the way, here's a product, its key is number 710. And so in the same sort of mechanical fashion, I can pick up that key, append it to the URI, hit enter, and that effectively scoped the set of all products to a single product. And now if I look at the data returned, I can see that there were some link elements. Some of the link elements are titled related. This is just some standard Atom goo that they tell you, oh, by the way, there's some stuff related to this product. And the thing that's related in this case is a category. And so if I want to go get the category that is associated with product number 710 in this case, I simply lift up the name of the associated link, append it on, hit enter, and now this gives me the category associated with product number 710. And if I wanted to roll back now into the particular product, I hit this, and I can see that there was data that came back for that particular product. It had a name, a list price, a color, whatnot in this case. And so if I can drill into any one of those in the same way I just did. I lift up the name, in this case of the element. So for example, I'll lift up the photo property. I'll hit enter. And what came back is now just the photo that's associated with product number 710, or that is on product number 710. And then we have some other fancy like app level things that let you, in this case, for example, it's a dereference operator. It says, you know what, here's the bytes for this particular photo. Don't give it back to me with XML stuff around it. Just give me the raw bytes. And the system's smart enough, after you've annotated your model, to be able to pass it back in a way that a web client can understand. So in this case, you see an image. I picked obviously the worst one, but it says no image available. But that itself is an image. And so if I right-click on this guy and I look at the properties, we can see that it's an image, and the image is being served directly out of the data service. But the idea here is that I'm interacting with my service just by appending URIs, looking at the data returned, and creating new URIs to traverse all the interesting points I might want to get at in my data model. I've only touched on very few of the things that are supported in the URI, but if you go look at the recordings from earlier sessions in the talk given by Pablo, you'll see a whole host of rich things that you can do in the URI space. And so, again, the way I interacted with it was just using a mechanical set of rules to point at the particular pieces of data. And obviously, I'm using the browser. The browser just does standard HTTP. And so we're not doing anything special here for my interaction model. We're just using standard HTTP gets, puts, posts, and deletes to perform CRUD operations on this data. So what I've been saying is that we've got a uniform interface, and we'll look at deeper in this talk how that plays out in sort of some of the real-world solutions you might be building. So let me close this down and flip back to the slides quickly. OK, good. Too much flashing. So that was just like the brief, very quick executive summary of ADONet Data Services, what we're trying to do, what we're trying to build. Again, I point back to some of the recordings if you want a deeper dive into the core feature set of data services. What I want to do, though, is spend the majority of my talk on some of the common problems that you might face, or at least that we've been hearing from folks when they're trying to go out and build data-driven AJAX apps or data-driven Silverlight apps and whatnot. And so I came up with, or like the team, excuse me, came up with the list of these 5 things. And basically, how we came up with these is we've been presenting on Astoria and its feature set for a while now. And when I say Astoria, it's just analogous to ADO.NET Data Services Framework. It was just the code name for the project, and I haven't quite got it out of my system yet. But we came up with this set of 5 things based on all the feedback we've been hearing after we've been presenting on the technology. People said, hey, I'm trying to build this app, but I'm running into this situation. Do you guys help there? Do you not? Is that the right mix? So I'm going to try and cover some of the key things that we've been hearing, or at least the common things we've been hearing with this 5. And so the first one is, I'm building an AJAX app, or I'm building a Silverlight app, or a rich desktop client, and now I'm spending a lot of my time writing client-tier code. I was traditionally writing a lot of mid-tier code. What does that mean for my programming model? Does my programming model significantly change now when I move on to the client tier to consume one of these services that you guys are creating? What about sort of the tooling experience and the data binding experience? All the nice things that I'm used to in the mid-tier. How does that play now when I'm writing a lot of stuff on the client tier? And more importantly, does that play nice now that all my code is on the client tier and my data source is all the way across the web? Whereas typically before in my mid-tier, my data source might have been relatively close by in a database where the latency characteristics were much different. How does that work? Can I reuse some of the best practices I've been using over the last few years? And so we'll talk about what we've done in data services to try and help with that. And so number 2 is kind of the big goal that everybody is trying to, or the primary goal that everybody's trying to get when you go and build an AJAX or a Silverlight app. You're trying to increase sort of the user experience, or make the user experience a little more crisp in your applications. And so an interesting fallout of that is that we've moved all this code to the client tier, and now to build a data-driven app on the client tier, the experience is fairly coupled to how efficiently you can use that data channel to go back, talk to the mid-tier, and pull down data to drive the user experience. And so what we'll talk about with number 2 is how can you effectively use the data channel between your client tier and your mid-tier, whatever services you might be consuming, such that you have a very efficient use of the data channel and have a crisp user experience. And at the same time, you think about, I've been talking about one user experience so far. I've been saying, you're building an AJAX app and whatnot. What we've seen a lot of lately is people are tending to build data platforms, meaning that they've got a set of data they want to expose. They're building an app on top of it. Facebook is my favorite example. Lots of people think of Facebook as terms like the social networking site that you build your app, that you go and interact with their web page. But they also expose their data as a service for, additional app developers to go consume the data and provide rich experiences over top of it. So the other characteristic we hear with point number 2 is, how do I build a rich service tier that can drive all of these different app experiences, but at the same time is fairly secure? And so that ties into point number 3, which is, so far you've been telling me a lot about a data services experience and getting at data. How do I make sure that I have secure access and that it's not just a quick way to party on my database or my data store? And how can I integrate with some of the existing authorization and authentication investments that I've made in the past? And so we'll talk about that. The final one is, how do you manage concurrency? Like you've said in previous talks, it's all just Atom Pub, it's all just HTTP, you're not inventing very much. How do you pass around concurrency tokens? What if I have multiple users? My thing's a real system. How do you guys manage that? And so we'll talk about what we have in terms of concurrency controls and checks and hooks and all this kind of jazz in the ADO.NET Data Services Framework, and how that might be able to help when you're building out your solutions. And so the final one is kind of bucketed out from number 4. It's less of a general challenge of building out rich client-tier applications. It's more of the fallout after we've answered the first 4 when we're talking to people. It's more of, okay, I see what you're trying to do. It may or may not make sense for my application, but I see here that you've got ADO.NET in your name. I'm sorry, my data is not in a database. This is not the thing for me. We actually have two key scenarios with ADO.NET Data Services. One is exposing data from a database, and we happen to have a nice light up with the Entity Framework. The second key scenario is exposing any data model wherever that data model might be stored. And so that might be stored in a flat file, XML file, another web service, code layer, whatever it might be. And we'll talk about what it looks like to build a full read-write system with the same characteristics that you get over top of a database, even if your store is not a database. And the next one after that is we talked to some folks that have an existing database, it's well baked, and they've got it all set up, and they say, this is interesting, but the access to my data when I'm doing inserts, updates, and deletes is only through stored procedures. I'm assuming that doesn't work. And so there is support for it in the system, and we'll talk about how to enable that as we go through the talk. So these are the 5 things that are going to frame the rest of the talk, and we'll go through each one individually and kind of take a deep dive to see how they can help or may be able to help when building out your solutions. So the first one was all about leveraging existing assets. And when I think about that, I think a lot about enabling reuse. And so the typical question that we've been hearing is, now that I'm writing and pushing all the presentation information, all the behavior logic to my client tier, do I get the same type of developer experiences that I'm used to? Meaning, can I leverage all the new investment in language integrated query and all the new stuff that came out in the language in .NET 3.5? And I'm used to data binding in the mid-tier. How does that work now? I don't want to have to go do all of this stuff on my own. And so the list underneath it is some of the things that we're doing in ADO.NET Data Services to help with that, to build out sort of the same rich ecosystem you're used to on the mid-tier, but now couple it with your applications that are client-tier centric to give you that richer experience. And so instead of walking through each one of these, I thought I'd just show examples of each of these in action in sort of the traditional things you might be building in some of your applications, or at least looking to build in some of your applications. So let me flip back over here. We're going to drive the demos off the same schema that we have right here. So again, there's customers and orders and whatnot in the service. Let me flip over to the Solution Explorer, hopefully, and give this guy a run. And the first thing that we're going to look at is an ASP.NET page. It looks like just a standard thing. There's a grid bound to a bunch of data. The interesting part about this is that this grid was bound using an Astoria-aware data source control. So to create it, I newed up a data source control. I dropped down just a standard ASP.NET grid. And now from the mid-tier, in this case my ASP.NET app, it can go off and talk to any data service that's out there and bind to existing ASP.NET data source, ASP.NET UI controls. So you can imagine taking down a grid, giving the specification to the data source control, and having that grid light up based on the data in a data service. So now that we've seen what this guy looks like, it's standard stuff. It can do sorting and all that kind of jazz. It can do full CRUD, edit, delete, what have you. I'm going to pull it down, and then now let's kind of look at what the code behind enabling this was. Bring this guy up, go to the source, and here. So this was effectively the new thing. It's an ADO.NET Data Services aware data source control that the only specification I give to the control is the URI. And the default entity set I want it to expose. So the specification I gave was the root of the service we've been interacting with. And I said, please go and display the customers. And if you went to Pablo's talk earlier this morning, you've seen that this type of URI experience and the way to build out URIs is uniform across all the Microsoft properties, or at least the Microsoft properties that are playing in this space. And so if you're building out your own service with ADO.NET Data Services, you can bind to it using this approach. Or if you want to go suck down data from a Windows Live service and bind it to a grid or any of the existing ASP.NET controls, you can also do it with this approach, because Windows Live speaks the same protocol that ADO.NET Data Services speaks. So that's the first one. And so not a lot new, just saying, you know what, even in the mid-tier you can play in this space. And so the other one that I wanted to show you was a little AJAX grid. So what some of the folks on the team did is they went and implemented the same type of thing, a full grid, but now it's running on the client tier, and it's just the same type of grid on the client tier using AJAX. And the only specification I'm going to give to this grid is the URI, which is bikes.svc. I want it to light up and display the data from /customers. So we saw in the data model we had customers. And I'll actually give it a hint, and I'll say, you know what, when you first order the data, please order it by customer ID instead of something else. I could leave it off if I wanted to, but we want it to display nice right off the bat. And so that's all the specification I give to this control. And now when I run this guy again, I go here, I hit it, and let's try and stop this from happening each time. Did the proxy detection thing going on. So there we go. Stop detecting the proxy, we know where we're going. So now we can see the control, that AJAX control. And again, the only specification I gave to it was this URI. The control inherently knows how to interact with the service because the interface to the service is uniform. And so now what it does, it says, oh, by the way, I see you've got some properties that are sortable to me. So if I hover over, they become links. And I can say, oh, I want to sort by customer ID. I can do that. It recognizes to the fact that some of the properties are special and they represent relationships. And they say you can't sort on relationships. And it says, oh, I'll just display a relationship as ... But you can imagine enhancing this control such that it could do a master details type approach, again, with no more specification than we've already given it. I'm just not the greatest JavaScript developer, so this is as far as I got. The next thing it has also is paging. So now you can see I'm paging over the data. And what I did is I displayed the URI that's being generated and sent to the data service as I'm interacting with the control. So as I hit a page, the only thing that's coming down from the data service is the exact number of records that I'm asking for to paint this particular screen. And so let's go roll back. And as I'm rolling back, it's grabbing the data for me. In this case, I'm actually not caching anything. And I'll sort it again, going the other way. You can see I've got one record in there. And as we've been doing so far, it's been all retrieval operations. But the system is full CRUD, meaning you can do full read-write over these things, so I support edit. And you can say edit on the thing. Maybe I'll change this to MIX08. Second one. And say commit. And now that's persisted it all the way back to the data source. And if I want to edit it, I say I don't like this one, I can hit delete. Same deal, now that the record's gone. And so as I'm interacting with this is actually persisting the data all the way back to the store. And again, I haven't written any code to say how to go do that, how to persist it back and whatnot. And you've got the same update or insert experience that you would expect. You can type in, hit insert, and it'll go. So those are two kind of examples of code reuse now that you can have on the client tier, meaning you can build out these types of controls that natively just understand the URI format and then can light up this way. So what I could do is if I wanted to not have this control be pointing at the bike service, I could change the service altogether and point it at Windows Live service, and it would light up just the same way. So let me walk out of this one quickly. And so far I've been showing a few UI experiences on top of this uniform interface. And one other thing that you could be doing is we were looking at, and we were getting a lot of questions about, I'm writing a lot more client tier code, and I'm used to being able to write in terms of .NET objects. And Link came along, and I'd really like to be able to leverage Link in my solutions. Can I use that now that most of my code is residing on the client tier, for example, in a Silverlight application? And so one of the libraries we're shipping along with the AWS Data Services framework is a library that lets you interact with one of these services in terms of .NET objects. So you just manipulate .NET objects, and we translate that into calls to this uniform interface. And we'll walk through this code to see what it's doing. So this class right here, Bikes Entities, this was just auto-generated based on a tool that we have. So in traditional web services fashion, we have this little tool that, given a URI, it spits out a bunch of types that are analogous to what's in the target data service. And so this tool spits out these types. This particular class represents kind of my session with the service, or at least my context with the service. And so I'm operating with the same service I have. And now when I want to retrieve data from the service, you can see I've got a links expression here. And so I query my services now with link. And if you map that back to what we were looking at before in terms of HTTP and using HTTP operations, what ends up happening is our link translator translates this link expression into a URI. And then we do an HTTP GET to this URI under the covers so that you can use the same type of rich language experience that you're used to in the client tier now in your Silverlight applications as well. So I'll show this really quickly. It's not all that exciting, but the idea is that now we're writing link against web services. And so if I run this guy, I threw in a breakpoint, and I'll show you why in a second. Let's get this guy to come up. So I broke right here. If I hover over the Q, I know it's really small, but what ended up happening is we translated that link statement into the URI that's being shown right there. So this is the URI that the link statement gets translated to, and now when I pull the data, the system effectively makes an HTTP request under the covers. So the idea is you get this rich kind of reusable client-side library, but you don't sacrifice any interop. Under the covers, we're still just using HTTP and URIs in the REST-based manner to access our data. So I'll run this guy all the way through, and you can see the query was for products with a list price greater than 500 that are red, and I did paging over it as well. I said, just give me back the first couple, and so you can see those right here. So there's that one. And so we've talked a lot about code reuse and the ability to reuse code in the client tier. I'll flip back to my slides just quickly. And so I showed a couple cheesy examples, ones that I created. But we've been working with a few forward-looking component vendors that have been kind of playing in the space and looking at what does it mean to leverage this type of ecosystem, and that you can build out controls that can light up against any one of these data services regardless of the schema of the data that's being exposed. And so one of those vendors, Component One, has built out a demo for us. And if you were at a talk earlier in the day, we tried to show it and we messed up and we put in the wrong URI, so it didn't fly. We're going to try again one more time. Hopefully we've corrected our issue. And so effectively what I'm going to do is I'm going to show a control that they've created. And it's basically a set of widgets that know how to interact with one of these services, again, because the interface is uniform. So what I'm going to do is bring up their application. WPF isn't my thing, so we'll just run it, and I'll explain what's going on. So run this guy. Oh, sorry, guys. Oh, now you can see what's going on. So again, control made by Component One. On the bottom, we have a grid. You can see sitting down here, we have a grid. On the top, there's this kind of carousel-looking thing. And effectively what's happened is the system's gone off. And what I've done is I've given it a URI to a service. And it's just one of the same data services we've been looking at so far, but this service is a photos service. So the data being exposed is photos, the actual photo itself, and metadata about those particular photos. And so the grid at the bottom is actually pulled back some of the metadata, and it's shown me all the albums that the photos are stored within. And now as I interact with the album, the system's going to, under the covers, go and pull down the particular photos and the metadata about those photos. And I didn't give it any specification to tell it how to do that. Basically, you just give it the URI. And again, because the system is linked and uniform, you can build these types of experiences with very little input into the system. So we've got two controls in my app sitting right here. The point that I glazed over to get to here is that the data we're going to pull from is actually data that's stored in one of my Windows Live accounts. So if you're at an earlier talk, you know that you can pull data out of a Windows Live account. So I've got, in this case, I've got 3 albums up in my MSN Spaces account. You can see I've got second kickoff meeting, design meeting, kickoff meeting. And I've got those same guys being pulled down here. And so far, what's happened is the system, given one URI, has pulled it down and displayed it in my particular grid. And now as I interact with one of them, it goes and pulls the photos that are inside of those particular albums in my live account. And so I've pulled those, I switch albums, it goes and pulls the next set and whatnot. And so I'll switch albums one more time, and there's this guy. And maybe I want to bring this guy to the front, so it does something much cooler than I could ever do and brings it around, which is pretty awesome. And then maybe I've named this photo outside number 3, which is probably the worst name ever. And so I hit edit, and I can now edit the metadata associated with the photo. And so I'll change this, and I'll just say, who's some people in there? So I can see Pablo's in there, so I'll call it Pablo. And I'll hit apply. And what this is doing is it's going back and persisting that all the way back to the particular store, in this case, Windows Live. And what I can do is I could add a new folder if I wanted to. So I can say Mike, or at least MKE, and again say that the author is actually Mike. And I can go back, and you can see the system now understands how to go create a new folder. And if I wanted to, I could upload myself a particular picture. So I'll pick a picture from our last ski trip on the team. So I'll call it ski and I'll say apply, and there we go. And so the folder, now we pick up the picture and we persist it all the way back to the data service. And so what I've been showing is an application experience, a typical application experience that we'd expect people to build. But this one's interesting because it's built using 2 pieces of reusable code, where these reusable pieces can be put against any particular data service because, again, the interface to the service is uniform. So let me close this guy now. Get back to the slides, hopefully. There we go. Perfect. So go back here. So those were a few examples of code reuse that you get now on the client tier, and you can leverage some of the existing experiences you've been used to. The next common problem that we had in the list, which is probably the most key out of any of them, is that I'm building an Ajax app, and the whole idea of my Ajax app is that as the user is interacting with the application, the app has to turn back and get the data to drive the user experience. So as I'm clicking through screens and whatnot, in the background, a typical Ajax app is going and pulling data to drive the user experience. And so you can imagine that in those types of situations, the user experience is fairly coupled to your ability to use the data channel between the client tier and mid-tier effectively or efficiently, so you're minimizing bandwidth, minimizing the number of hops you need to make between client and service tier, and minimizing the latency of these particular calls, or at least of the experience to the user. And so, what's listed here is a lot of the features that have been gone through earlier in the talk that data services provide to enable you to make efficient use of a data channel between client and mid-tier. And so typically what people have been asking us after we go through this laundry list of features and show them at the protocol level is, I say, that's interesting, but how do I integrate this into my app? Can you show me an example? And so with that, I'd like to invite Galen and Greg to come up on stage from Veracity Solutions. And Galen and Greg have been building a solution for the medical space, which is a rich Ajax solution. And they've selected data services as sort of their data channel between their client tier and their mid-tier. So with that, I'll give it over to Galen to describe what they've built, and Greg to walk us through it as an example of a real-world app using these particular services. So guys, it's all yours.
Fantastic. Thanks, Mike.
Yep.
Speaking of Mike, am I on? You hear me all right? Very good. At Veracity, we build software solutions with software companies. Our goal is to build products that are excellent, and ADO.NET Data Services has helped us achieve this. And today we're proud to announce Freenatal, an open source electronic medical record module that is used for prenatal care, or in other words, something that allows doctors to track information about pregnant women and the babies they're carrying. We built this in partnership with one of our longtime customers, Mises Healthcare Systems, who is one of the top 5 healthcare IT companies in the nation. And it's important to indicate that this is a production application today using publicly available bits. And we're excited about that. And that indicates that these are stable bits that you yourselves can also build real-world applications on. Just as a quick show of hands, how many folks have downloaded Astoria today and have perhaps built something with it? Okay, a few hands. How about Entity Framework, ADO.NET Entity Framework? Okay, a few more hands. That's good. We used both of these technologies. What I want to do just briefly before we show you the product is frame the business problem that we were going after. Particularly, doctors need to be able to access their patients' information from at least 2 sources, looking at obstetricians in particular, the clinic in which they work and the hospital in which they deliver those babies. And about 90% of doctors who provide prenatal care don't use clinical systems, electronic medical record systems. So there's a huge gap in delivery, with doctors faxing paper back and forth, and a lot of opportunity in the space. And we think that this open source offering is the right tool at the right time. We also needed to be able to support a variety of user interfaces. While this is a great web app, we didn't want it to be the only way that the doctors could get at this information. So we knew that we wanted to build it on the web. We knew we'd have a back-end store in SQL Server. We love Entity Framework and what it provides, and so we chose that as well. But we had that problem that many of you might be facing right now in your applications. How do we get that rich data down to our Ajax client in a way that doesn't involve writing a bunch of custom WebGets and our own custom services? How many WCF lovers are there out there? I'm certainly one of them. WCF is a fantastic technology because it allows us to provide a lot of service-centric and operation-centric operations. But if we were to try to do all the CRUD that we're achieving in this application today, we would have spent twice as much time on that layer. And so ADO.NET Data Services has helped us greatly in productivity. It's been highly performant and highly secure. So I'm Dr. Mark Sloan, and I'm going to switch computers here. Come over and introduce Freenatal. I'm going to sign in. And today I'm seeing Miss Grace Kelly, who's carrying a baby, but she's having some pretty particular difficulties, and I want to show her that. On the patient screen, I see first the list of patients that are soon to deliver. As Greg will show you briefly, I can see a variety of information about those patients and sort to find them. But I see Grace Kelly right here, so I'm going to go and select her. After a brief review of what doctors call a face sheet, the sheet that summarizes her key information of problems and medications and allergies, I want to record some information about the visit that I'm having today with Grace. You know, her belly is coming along nicely, and I'll record some measurements here. The presentation's looking good. The fetal heart rate is a little lower than it was last time. Might be a boy. Is moving well. No preterm labor signs. And I'm not going to put her through the pain of a cervix exam. But I noticed that her blood pressure is a little higher than it should be. And I talked with her a little bit further about her drop in weight. And that concerns me quite a bit. I'll persist that information. You know, I'm doing this right in front of the patient. And I find out that, in fact, she's been really nauseous and hasn't been able to keep her food down a lot. And I determined that it's a condition known as hyperemesis. This is a pretty nasty condition that my wife has actually had. It's not very fun, but it's very treatable. So I want to record that and talk with her about that. I'm going to go over here to history and exam. Remember that, oh yeah, okay, she has one child already. Some brief information about this particular pregnancy. And I'm going to come over here and remember that here it is, the third trimester. And I want to talk with her briefly about fetal movement monitoring. I want to make sure that baby's doing well, even though she's doing pretty sick. That's supposed to say nausea, but I won't bother you with the spelling. And finally, one of the things that I want to make sure we can do is lots of water. And I've also talked with her about IV treatments and our regular clinic. Finally, I'm going to come back to the face sheet and make sure that I can prescribe a great medication, Zofran. It's an orally dissolving tablet that allows women, despite the fact that they can't keep their food down, to do well, nonetheless. So just after meeting with her in only a few minutes, I can now exit my record with, prepared to see my next patient. I don't have to put it on paper. It's instantly accessible in a variety of different user interfaces, and the patient's really receiving better care. Now, to walk us through a more deep example, I'd like to turn the time over to Greg, one of our senior developers.
All right, thanks, Galen. Freenatal is a clinical application, and as you can see, it demands a really quick user response and fast data retrieval. And in this case, we're able to accomplish that by leveraging the ADO.NET Data Services, as well as leveraging cached HTML templates. So all the rendering you see here is done on the client. There's no server rendering at all. So for instance, on this entire page, as I interact with the different fields on this page, the data is automatically refreshed and none of it's cached. So if we take a look at the list of providers, as I select an organization, all the patients as well as all the available providers are automatically refreshed from the server. As well as I can go ahead and do a search for a patient by name, as you saw here, and really quickly it gets back those results for me. And even the sorting is incredibly fast. And all the data you see listed is coming from the server every time. If we go down and take a look at the actual query that's happening against the data services, you can see that we have a VW patient search, which is a view from the entity framework. And we're filtering by active patients, and we're ordering by organization. If I go ahead and expand that, you'll see the actual JSON results that are coming back here. Very simple list of patients that we can easily bind to these templates that we already have cached on the client. So once they're retrieved, they're stored and reused, but the data is retrieved every time. Another nice feature you have here, and by the way, if you're not familiar, what we're using is Firebug down at the bottom. It shows us all the AJAX interactions that are happening in the application. It's a good tool to use. As you saw with Galen, when you mouse over some of the major columns here, you can get additional information about a patient, an organization, or a provider. Normally, when you do this, you'd have to get it with your entire list of patients or render it on the server and then retrieve that content. But because of the speed of data services, we're able to retrieve it right as you mouse over a patient. So if you take a look down at the bottom, there's a request and there's our data. Really fast. Less than a third of a second to retrieve it if you look at the round trip time. And before Easy Receipt, it was also less than a third of a second to get all those patients. That's the time that it takes to send off the request, get back the results, and populate it to the page, all in less than a third of a second. So you're going to see that you can achieve these really rich experiences even in ASP.NET AJAX. So I'd like to take a minute to talk about the technologies that are used here that you're seeing. The first one is ASP.NET AJAX, as I talked about. That's used to give us these rich class hierarchies that enable us to be able to render this on the client and be able to handle these quick user interactions. It also gives us the history management. If you look at the top here, you notice that you have the current page tab and the content that we're displaying. And as we navigate throughout the application, that updates and it can be bookmarked, and you can use the browser functions forward and backward to get through that. Another problem that we had to tackle with Freenatal is being able to add a patient. If you look at this screen, there's a lot of information here. There's information for the patient, the name and contact information, and there's also information for the pregnancy. The information for the pregnancy is father of the baby and newborn's physician. So when a user clicks save or save and continue, we have to persist all the information to our data store. And involved in that is, of course, the ADO.NET data services. And we're using the data service class in JavaScript, which allows us to simplify that AJAX interaction to just a few lines of code. It's been really nice to use. And of course, SQL Server is our data store. And we're using the entity framework to be able to generate the classes needed to interact with the data services. But back to the data here. When we do this insert, we're taking a patient and we're also taking a related pregnancy and we're combining those in a JSON object. And then when that insert's performed, if any of the data is invalid in either object, the insert for both of them fails. It's a really nice feature, and there's not a lot of work we have to do to make sure that that happens. If I go back to the patient list, let's go back into Grace Kelly here and take a look at this EDD update section. EDD stands for Estimated Date of Delivery, or the day that the baby is due. As a doctor updates the EDD, it also needs to update the pregnancy. You'll notice at the top here, there's the current EDD. And so as these individual items are entered, this needs to be updated on a pregnancy entity. So we're dealing with different circumstances here. We still have two different entities. We have an EDD audit table and we have a pregnancy table. And in this case, we can't use a deep insert because we're doing an update on an existing pregnancy and we're doing an insert into an EDD entity. This is where the data services JavaScript class is also very helpful. It allows us to use an action sequence, which allows us to queue up the update and the insert and be able to perform in a single dependent transaction. So again, if any of the data is invalid, it fails and neither of them are performed. So let's go ahead and add one here. So as you can see, that immediately updated to the new date. Very nice. Now if we go over to the history and exam, we have a section here for past pregnancy. Past pregnancy is able to take advantage of the query, the insert, and the update. So if we go ahead and enter just a couple lines of information here. And if we save that, you're seeing the result come back immediately. So what's happening there is an insert's being performed and a query is also being performed to get back all the past pregnancies. And that's to help get around that concurrency issue. We want to make sure that the current data is always being displayed to the user. If I go ahead and click on this item, it's going to take me into an edit mode. What's happening in the edit mode is that data for that single record is being retrieved very quickly and then being displayed to the user to again avoid that concurrency issue if another provider has been editing that patient and maybe it's been open for a while on his desktop. And the speed of the data services allows us to do that very well. Then as I click save, an update is being performed and another query to get back the current list. Over on comments, let me go ahead and expand Firebug again here so you can see some of the transactions that are going to happen. Let me go ahead and add another pregnancy comment. Sometimes these small keyboards, they win. Okay, so I went ahead and added it, and at the bottom you see a post, which is the equivalent of the insert, and then you see a get, which is getting me back all the comments again to make sure that I have the latest information. If you take a look at the composition of the URI, you see that I'm getting a pregnancy general comment that is related to pregnancy 1, which is the current pregnancy I'm viewing, and I'm also doing an expand on user 1, which in this case is the last modified user. So without any modifications to the underlying data service, we're able to go ahead and retrieve this additional user information that you can see displayed as I mouse over the date and the provider initials. Very easy to do and very quick with these data services. Another important issue, like Galen talked about, is security. With this application, we were able to set up basic forms authentication really easily, be able to secure all the pages in the website as well as the data services. And then on top of that, we were able to insert 3 query interceptors for patients, providers, and organizations to make sure that the current user that's logged in always has this data filtered so they're not getting access to other patients' records or organizations or providers that they're not supposed to have access to. And that really simplifies our queries throughout the application because we don't have to worry about that kind of information anymore. Now I'm going to switch over to NetVibes. As part of the Freeneal application, we wanted to make sure that the doctor could get access to information on his own terms. And so using the same underlying data service, we were able to go over to NetVibes and quickly implement a widget that allows him access to some basic patient information. In this case, instead of JSON, we're consuming Atom. And it still works on the same underlying service. Sorry, the internet connection is a little slow here. There we go. So if I drill in again to Grace Kelly, you can see a summary of her medications, allergies, and problems. And also Nicole Kidman. Let me go ahead and turn it back over to Galen here, and he has some more to talk about for you.
Fantastic, thank you. In just a brief minute, I want to summarize some of the key points that we found as we developed this. We've got plenty of ideas, plenty of feedback, so if you want to talk to us more about it, feel free to come up after. But in interest of the remaining time, I just wanted to reinforce some of the key points that Greg has talked about. You saw performance, that was a key piece. A lot of folks, even on the ADO.NET Data Services team, were surprised at how fast this worked. Productivity was important. We would have spent, with the order by, with the expansion, lazy loading, eager fetching, whatever you want to, whatever your favorite term is, with the filtering capabilities. You can imagine in WCF the number of service operations that we would have had to write to support that capability and the rich client intelligence that we'd have to do to support that just-in-time fetching. But ADO.NET Data Services has that out of the box, and it was precisely what we need in an application that 90% of which is CRUD-based operations. And we can still have service operations for prescribing a medication and going deep with drug-drug interaction checking and beyond in a full services tier. You can have rich business logic behind your data services facade. It's not just a data access layer on the web at all. Sys.data, the library built by by the ASP.NET 3.5 team, is what we're using. It's a great, straightforward application. You don't need to be a JavaScript guru to be able to do all of this, and they've really made it accessible and easy. Finally, security and integration. 2 quick points I want to hit. The real application runs over HTTPS. We didn't want to deal with certificate issues during the demo, but the real app uses forms auth and HTTPS so that all the information at all times is secure and HIPAA compliant, which is important for healthcare. Final point for integration. REST is excellent in, as you saw with NetVibes, but it also allowed us to, in this same example, allow one of our partners who has a Java-based integration engine to access that same service for printing a PDF copy so that doctors who still need that paper reference can have it. And that likewise that engine, using the Atom format, can transform that XML into PDF, put it in a document repository for later sharing. And we demoed that sharing at the nation's largest healthcare conference last week, HIMSS in Orlando. We're very pleased with the team at Microsoft and pleased with the technology. Without sounding schmaltzy, as a consulting firm, we have a lot of stake in choosing and making the right choices and in choosing it based on the right people. And we're very pleased to have met with Pablo, with Mike, and with all the members of the data services team, including the members of the Entity Framework team. And frankly, they get it. They're individuals that we're proud to be associated with. And we expect that as you investigate these technologies, you'll have a similar experience. Thanks for being here today. We appreciate your time.
Thanks, Galen. Okay, we're going to try and get up and going again. Of course, every computer we have up here went to sleep, other than the one they were using. So we'll try and get them all going quickly. All right. So that was sort of the first 2 common challenges that we walked through already. The next one is kind of a follow-on. After seeing these types of experiences where data is being fetched or stored in a whole bunch of interesting ways, inevitably the next question we get is, that's great. Have you just let people party on my database? And so what I'd like to touch on is controlling access. How would you go about controlling access to one of these services in your applications? And so as Galen was touching on, he mentioned other technologies such as WCF and whatnot. The way that Astoria, or the 809 Data Services Framework, is architected is that it's a framework, and it's hosted then by other platform components. So the demos I've been showing so far is Astoria within ASP.NET and WCF. And because of that, that layering within the system, the framework itself isn't in the authentication business. You never really want to have to create your own authentication scheme unless you've got some specialized need that warrants it. And so what we let you do is basically, for authentication with one of these services, leverage any of your existing investments you might have in ASP.NET Forms authentication or HTTP Basic authentication or whatever it might be. And then for authorization, we recognize the fact that all the solutions you have and the various businesses that you're in typically have different requirements on authorization policy. And so we tried to give you a rich set of hooks, an efficient set of hooks that let you easily implement any authorization policy you might have. And so instead of talking through it much more, what I'd like to do is just show you an example. I'll take one of these services and effectively start locking it down and implementing policy on top. So I'm going to switch over to a demo I have created here. And if you're familiar with data services, or you've seen one of the other talks, the way you create a data service is you subclass the data service class. And once you've subclassed it, you point it at a set of .NET objects that represent the objects that you want to have exposed to the web. And so in our other example, we exposed bikes. So I was passing in a bikes class here. And once you've got that, you're ready to up and go. But at this point, there's no authentication, there's no authorization. And so what I'm going to do is take this existing service, and we'll run it just quickly to see what it looks like. Go back down. And I'll walk through this and how I made this pop-up happen. So we've got a contact service here. I'm just changing the schema a little bit to something that's really trivial. We have a contact service. You can imagine doing something like an online address book where there's users and contacts are associated with a user. So as a user, you can go in and add and update and whatever on your contacts. So you can say /users and go see all the users in the system and whatnot. So right now I've hit /users, and you can see that all the, well, effectively 2 users are showing up. That happens to be all the users that are in my particular system. But you can imagine if you're building sort of an online address book type thing, you don't want everybody to be able to see all the users that are in your particular system. You typically only want somebody to be able to see their own account and the contacts associated with their own account. And so what we're going to do is look at how you'd secure this system such that you limit people to only being able to see the data that they should that they have the rights to see, and then we'll look at the authentication piece of it as well. So going back to the service, what I have here is an ASP.NET page. I have the service hosted inside of ASP.NET plus WCF. And what I've done is I've implemented a custom ASP.NET module. If you're familiar with those, basically it's a little bit of code you can plug into the ASP.NET processing pipeline. And what I did is I implemented HTTP basic authentication. There's bits in the system that can do that for you, but to prove out the point that really you could do anything right down to a custom scheme, I went and implemented HTTP basic on my own. And so here's my module. You can see it's got a whole bunch of goo that implements the HTTP dance. Typically, you'll use the system-provided stuff here. But the interesting thing is I've got one method. And what ends up happening is after the HTTP authentication handshake happens, this method gets fired. And it says, OK, the user made a request to you. They provided credentials. They provided a username and password. Do you know about this user? Is it a valid user? And so what I've done is I've integrated with the ASP.NET membership provider infrastructure to go and validate, is this user actually stored in my set of known users? And so membership.validateUser is just a standard API from the ASP.NET space where I pass it the username and password, and it comes back and tells me, yes, if it's valid or not. So at this point, you've done HTTP authentication. You've taken the credentials, validated them against your ASP.NET membership provider. And then we know who is making a request to the system. And at this point, we want to be able to lock down particular pieces of our data model based on the credentials that somebody's provided. And so the way that you do that in Astoria is, or 809 Data Services, is on the class that you've created that represents your core service, you create what's called a query interceptor. Query interceptor effectively lets you look at anything that's coming into the system, in this case for retrieval, and lets you make decisions based on it. So if I expand this guy, what I've got is effectively when a query to /users comes into the system, this code is going to get called. And what I'm doing is I'm saying, if the particular user associated with this request is in the role admins, then I want to, yeah, that's fine. I say, you know, they can see anything they want. But if a user that's coming into the system is not in the admin's role, they're in the user's role, then what I do is I take the principal, or the http.context.user.identity.name that got set from my HTTP basic auth module. We didn't look at that step, but because we're integrated with the ASP.NET membership provider, this happens. I get to see this piece of code that represents the incoming request or the credentials on the incoming request, and I say, OK, for all the users in my system, only give back the set of users where the name property for that particular user entity is equivalent to the name that you provided in your HTTP credentials. So effectively what's going to happen is somebody's going to try and hit the site. They're going to hit /users. The dialog's going to pop up. I'm going to give my username. And then that's going to get pushed into the data service. It's going to hit my authentication module. My module is going to check it against the ASP.NET membership provider. Membership provider is going to say, OK, I know about this guy. It's going to set http context.current.user.identity.name to the credential of the incoming request. And then this interceptor gets fired, and you get to implement the authorization policy in your system. So let's run this guy end to end quickly, and we'll see it working. So let's try and hit /contacts users. So I'm going to hit users just like I did before. This time I'm going to give the credentials of somebody who's not in the admin's role, but somebody who's in the user's role. And so I hit this, and I'm going to give Pablo, because I don't trust him at all, so I put him in the user's role. And I hit go. And now you can see what came back is just one user instead of the collection of all users in the particular system. And why that was because that interceptor got fired. So this time around, let's run this guy under debug and watch what happens. Knock this down. Contacts, users. Let's give Pablo again. Pablo is in the user's role. Hit go, and you can see that my interceptor here gets fired. And as I walk it, it does a roles check. This roles is just, again, APIs that are provided by ASP.NET. So using its role provider in this case, it says, no, he's not in the admin role. Is he in the user's role? He is. And let's look at the context provided. Okay, it was Pablo. It was the one I typed into that standard prompt that IE gives me. And if it's correct, then I end up appending onto the query. I let it run, and it gives me back only the user account associated with Pablo. And then similarly, if I try and access Pablo's contacts, I get scoped in such a way so that Pablo can only see the contacts in his particular account. So that's a very quick walkthrough at one way to secure an ADO.NET data service, in that you can use the hosting environment to leverage any existing investment you've made in that space. So for example, if you're using an ASP.NET module today, you can just continue to use your ASP.NET module as a way to authenticate requests into your service. And then when you go to build the authorization policy, given the user, what can they do? You can use the query interceptor mechanism that we have, where you effectively get a chance to implement whatever authorization policy you might want. And you can see in this case, I integrate in with ASP.NET role provider infrastructure. So that's a brief look at access control. And I'll flip back over here. Coming back, coming forward. The next common question we get about the system is, okay, I've seen how you interact with data and how you can make this efficient for me, and we know how to lock down the system, but what about concurrency? I have multiple users. In all the talks I've gone to so far, we talked about that the interaction model is just HTTP, you're using Atom, you're using JSON. How do you go about supporting concurrency? And in general, the system supports an optimistic concurrency approach. And what we do is, it's the same story. We just use HTTP wherever we can. And so for that, what we do is we pass concurrency tokens or original values in the form of HTTP tags. I'm not going to go into it in too much detail, but it's, what I did want to point out was that the way that we transfer this concurrency tokens on gets, on inserts, updates, and deletes is just using a standard HTTP mechanism called e-tags. And so it'll work in your browser. And in fact, any HTTP stack will handle a lot of this for you. You just set up the headers, and it'll transfer it back and forth. And we don't have to invent anything in this space. And so the typical flow that you'll see is that if I do a get against a particular set of users and I get back a single user, what comes back in that request in the first arrow is an e-tag. The value of that e-tag is representing the state of the user that I got in this case. And then if I try and go back and update the user, when I go to update the user, along for the ride in the update will come another header that passes back the token to the server and says, you know what, I'm making this update based on the knowledge that this was the state I last saw. And then just using standard HTTP semantics, the HTTP protocol will look at that, and you can do a comparison and say, you know what, is this value still the original value that we have on the server side? If it is, the operation continues. If it isn't, you'll fail with a sort of a concurrency violation. And so the point I just wanted to make here was that we invent very little here, and again, we're trying to integrate with HTTP where we can. And so I'll go through this one to get to one of our last items, which was data sources. And so a typical question that we get is, now that I've seen what Astoria is and the problem it's trying to solve, it might work for my particular solution, but my data is not stored in a database. But my data, at least when I'm inserting, updating, and deleting data, the only view I have into the system is via stored procedures. How can I implement these types of experiences if I have either of these two situations? And so what I'll do is flip over and show you both of these. And so the first one is, what if your data is not stored in a database? Can you still get this same type of rich data service experience? And for that, I'm just going to stay on the same contacts or users and contacts service we were just using. And what I'm going to show now is the contact data class itself. For this particular service, all the data is actually residing in memory. It's not going to a database. It's just a set of in-memory collections. And I've used that as the simplest way of showing that you could create one of these services over any type of data source. In this case, it's a trivial in-memory collection. So let's look at what we have here. If I expand this guy, you can see my contact data class, which is representing the data model the service is exposing. And here's that class. That class has two public properties. It has a contacts property and a users property. Both of them are returning something of an iQueryable of a particular type. How the system works is it translates each one of those public properties into slash something. So in this case, we have slash contacts and slash users. I'll show you one of them just to show you it's a trivial thing. You can't access contacts directly. And users, we just return a queryable object. And now what I'll do is I'll show you each one of these contact and user classes just to show how it was implemented out. The contact class pretty much just defines the shape of a contact. Has a contact and a bunch of properties, nothing else. The user class, same deal, except now it has a collection of contacts. So that's a note to the system that, oh, by the way, users are related to contacts, and every user has a set of particular contacts. And then the way that the data is actually being populated, as I said, it's just a bunch of in-memory data, and so it's not all that exciting, but I've got a couple lists. I stick a bunch of data in there, and then effectively the data service is created on top. So this is how the data is being generated. You can see I have a contacts collection and a users collection. Let's look at the __ users. It's just a list of users, and I populated a couple. And so if I walk back out and I look at this iQueryable of users, you can see all it's taking is that same collection, returning it as a queryable to the system. And at that point, implementing a class with public properties that return iQueryable, and then implementing, obviously, the types that are inside of those properties, that's enough to get a read experience over top of your data service, or sorry, over top of your data source. And so my data source, again, is just in-memory lists. And at this point, I can do /customers, or excuse me, /contacts, /users, and do all the same type of traversal operations that we were showing earlier. But obviously, the next step is how do we do write on top of one of these things? And so for that, we've defined an interface called iUpdatable. And what you do is you implement iUpdatable on your contact data class. And once you've implemented that, you'll get full read-write on the system. And so let's look at what iUpdatable looks like. I've only implemented the insert path just as an example of what happens. So typically what happens in the system when you try and do a post against one of these services, say you're posting a new user. What we do is we take that data, we say, okay, you're trying to do an insert. You're trying to do an insert to a new user. Maybe the user's name is Bob, the ID is 2, and Bob's age is 8. And so what we do is we shred that data into the fact that it's a new user and it's 3 property sets, effectively. And then we call down to you in that manner, letting you handle each one of those operations however you might want on top of your data store. So looking at what iUpdatable looks like, you can see there's a method here called createResource. In an insert operation, this is the first method that gets invoked on your implementation. And so what I'm doing in createResource is I'm saying, if you're trying to insert a user, I go and create a new instance of that user class we already saw above. I'm going to set the ID directly, kind of analogous to a server-generated key. And then I've got just a list of pending operations. And so I'm going to say, okay, you're trying to insert a user. I'm going to put this into a queue of pending insert operations. And so I add that to my list. And that's all that happens. And so now I've got an empty user object sitting in a queue of pending operations. The next call that will happen from the system will drive into your interface, and your interface will say, okay, the next things we want to do is set the values on that new user object for each of the values you provided in the request payload in your insert operation. So for example, if I tried to insert a user with name Bob, I'd first get called createResource to create the user object. Then I get called setValue to set name equal to Bob. And the system gives you back the user object, the property it wants to set, and so on. And my code just goes off and sets all the properties one by one as you get called. The last thing in an insert operation is saying, you know what? Persist the changes. I've given you the new object. You've set all the particular properties. Go ahead and persist the changes. So for that, save changes gets called in your implementation. And in my implementation, all I do is I go and purge everything that I had in that queue of pending operations. And so in this case, my queue is only of size 1. It'll be of operation type add. And I effectively call add new entity, which, if I scroll down, all it's doing is adding to that in-memory collection of users. So that's just a quick walkthrough of how you could implement sort of full CRUD on top of any data source. What I should note is that this pending operation type and whatnot, these are just little helper classes that I invented on the fly here to make the demo work. But the things that you're implementing are the save changes method, the set value method, and the create resource method. how you go about doing that is just based on the interaction model of the particular interface. So that's a quick walkthrough of creating a service on top of any data source, not necessarily a database. And you can see we were using this in previous demos. We just didn't know that it wasn't a database. The next one was, what happens if the only view I have for insert updates and deletes is through a set of stored procedures? Can you still provide this type of experience in that case? And for that, I'm going to switch back to a demo we looked at earlier in the day, which was the bikes demo. And I'll bring up this model and bring up this mapping. And what I'm basically just going to show is that for this particular bikes demo that we had before, and I had the ASP.NET grid on top of it and the AJAX grid on top of it, where we're inserting and updating entities, all of the insert updates and deletes were actually flowing through stored procedures. And so the entity framework itself supports these types of mappings so that when you build an Astoria service or an ADO.NET data service on top of the entity framework, you just tweak the entity framework mappings a bit to say use these stored procedures instead of SQL, and then the system will effectively use stored procedures. So from the ADO.NET data services perspective, there's nothing you have to do, but at the entity framework level, you go and tweak your particular mapping. And that's what I've done down here. So I won't walk you through it, but in the entity framework side, you can just go and tweak particular mappings to support that scenario. So flipping back to slides quickly, those are all the sort of common challenges or common questions we hear about data services. And the last thing I want to talk about is something that's not in V1 of the product, but something more about a scenario we're looking forward at, we're exploring in this space. And it's all about offline. So give me 1 second to do a quick laptop dance here, and we'll get the next one up. And the offline scenario we're looking at is, so far I've been showing you a bunch of clients that are always connected or always online. So we've had the AJAX apps and whatnot, and they're integrating with these services when they always have an internet connection. And so the scenario is, what happens when you're offline? And so I need to find where this guy actually hooks up, and of course it's on the wrong side. So let me do that quickly. This guy up and going. There we go. Okay, quick dance here. Okay, so what I've got right here is effectively a Realtor's Assistant app. And the idea is that what I've done is I've pulled from my data service a set of listings and buyers. So every buyer has a set of listings associated with them, and me, their realtor, wants to record data about those listings. Maybe they've made a comment about the particular listing. Maybe they really like it. I want to be able to record that data. So before I've gone off on site with my particular customer, I've sunk all my data, or I've gotten all my data from the data service to generate this UI. And so that was great. I was connected. I could just make calls to the data service and generate the data for this UI. But now, if I were to go on site with the particular client, and as we're looking at a house, the client wants to comment on the house. So maybe they want to comment on this listing, and they want to say, you know what, my comments are, whatever, nice house. And so I want to record that fact that this person really liked it, but at this point, I don't have line of sight, or I don't have connectivity back to my data service. And so I can't persist this change all the way back. And so what I need to do is I need to store it locally. And so the scenario we're looking at is, can we provide a situation where you can take one of these data services offline, we automatically provision a local store for you that maps to the schema of the data service, in this case SQL CE, such that now when I hit save, the operation happens against my local storage instead of the remote data service, and then when I'm back online, I can effectively sync the two. So to prove what's going on here, let's look at the buyer listing quickly. And let's look, I'm just using a feature of the data services, and I'm effectively searching all the buyer listings in the service, looking for anything with a comment that says nice house in it. So it's thinking about that. Remember, the last store I made was, the last operation I made was while I was offline. So when we looked at this particular result, there's no entity that says nice house. So that means the save operation I just did isn't actually persisted in my data service yet. The save operation I've taken to put nice house here just was persisted against my local storage. And so ideally, I'd like to be able to now sync up the changes that I've made locally against the data service. And so for that, we're looking at some, a scenario where you could say something like, okay, go ahead and sync now. I've got some changes locally. You've got some changes maybe on the data service. We want to merge the two together such that I've got an accurate view of what's going on. And so if I say sync now, you can see the little thing in the bottom is, is synced, and it says, okay, sync complete. And so now if I go back to the data service, and I ask for all the listings where there's a comment that says nice house in it, and I hit enter, we can see that, oh, by the way, now there's a listing here with a comment, if I can find it, that says nice house. So the scenario would be when I'm back online, I can sync up my changes and have my local store sync up with my remote data service. This is something that we're looking at within the team. It's sort of early exploration work. This is a quick demo that we put together, and it's an area that we'd be interested in your feedback in this area. So, wrapping up quickly, data services are a framework to create and consume data services. They're all about targeting the web, making it easy for you to write rich client applications like Ajax or Silverlight apps. We have a quick sort of a special build we put on the MIX CD. It was just kind of a one-off thing. We took a daily build, slipped it on the CD so that if you want to play with these bits, you can. But keep in mind, that's sort of the quality bar. It's a daily build we were able to put on the CD that you get, so there will be bumps in the road. That said, if you want to wait a few weeks, then you'll see something. It'll likely be beta 1-ish type thing of the release of the particular product. And after that, we'll come in with the Ajax library and the ASP.NET data source control a bit after that. So if you want bits right now, you can play with them. A little bit rocky. You wait a few weeks, you'll get sort of the real deal. And we're exploring offline integration, so if that's something that interests you, we'll be around. We'd love to hear your feedback. And so with that, here's a few related resources, and I thank you very much for coming to the talk and exploring the space with us. Thank you.